Hi everyone, so I was refactoring the chess engine I made in Zig. So for example, if I show the regular function, it's basically spaghetti code. It's just massive lines of code, just constant, how many, I don't know, like thousands of lines in one function. I thought, how about we try to separate this into functions? So to neaten it up, maybe test the performance difference. The problem is, doing that, I created a lot of bugs. So what I decided to do was try to make it function based on functions. So I have this thing here, extracting the function. I haven't extracted that yet. I was testing it because I made a load of bugs. But here I make getMoves. But I was testing this using Zig's inbuilt testing. So I have a ridiculous amount of errors that could happen. What you want to do is basically just presume you're an idiot. Because most of the time, you will make an error, you will make a mistake, you will make a logical error, like some kind of flaw in your logic will be somewhere. So you want to presume that will happen. Because some of the mistakes I made were kind of stupid, honestly. So basically, I have a massive function where I'm testing everything. And you'll probably never get as thorough as error checking as this. So I perf debug. Alright, so I have all these debugging functions. So if the ply is 0 and the depth is over max, it's too high. Also, I should probably have something like, if depth is 0 as well. I forgot to have that. If depth equals 0, starting depth 0. Forgot to do that anyway. If the depth is, depth is low, it shouldn't go less than 0 because we have this if depth is 0. So it should get to this, return 1, and then stop. If it doesn't do that, we got an error, so return it. Say, here, for example, I'm checking if the white king was captured. Basically, if the bitboard is 0, it was captured. So I'm going to print all. I also print all debug because this actually did happen. The king was captured. I print all debug. What this does is it basically will print the last move and print the board position and print the tag and then print the capture index. Basically, just print all the information I need to know what caused the bug? Where was it? What situation? Obviously, just telling me there was a bug. Like what? Where? I need to know. So I also have this thing debug info, which basically I use to store the call count, how many times the function was called. I had the last target square. Just for example, here is the start of the function, so I don't have all the data of what the starting move was. It was in the other, the last iteration of the function. So I don't have it here. So I basically save it in the debug info and then pass that as a pointer. And then I can pass it here and then know what the last move was that captured the king. What captured the king? I need to know. So I have all this print debug. I didn't put it for every one. I basically put it in places where the error happened. So if the error didn't happen often, I just return. The black king captured didn't happen, so I didn't put this. If I found black king captured, I'd put this afterwards. Just because I don't want to copy and paste it over everywhere. It would be too many lines of code. So if white global, so here we get the combined occupancies. We just add and all the pieces together. Then we see if the white king is in check on black's move, because obviously black, white should never be in check on black's move. So we're checking for that. And if it is, then we just print it and print the board, because that actually happened. I did actually print the board, but same thing here. I'm doing all this just at the start of the function. We haven't even got to actually anything yet. This is just testing stuff. I'll close all this. Okay. I indented it just so this is debugging. What's not indented is just regular. So the call count, we get regular, like all the regular stuff. We get the copy bitboards. So we copy the bitboards to check. If we make a move, unmake a move, and they're not the same, then it will be an error. Then we have a load of more debugging. So we get the moves. In the getMoves, also have a load of debugging as well. This returns errors. It's not too many, but if white occupancies is 0, also a list of bugs here. getMove errors, not too many bugs here, but because most of them are done in perft anyway. I have some debugging for pins and check. But yeah, before this was spaghetti code, I kind of realized I was repeating a lot myself, and I didn't need to do anything. So white pawns are black pawns, black king, white king are in this, and the rest of these are simply just here. So it's just that, and that's all. Whereas the other time I was basically doing black knight and then white knight, and I was repeating the same code over and over again. I didn't need to. What I decided to do was basically have I have a rook index, queen index, knight index, and I set that here. So the knight index is white knight if it's white to move. The the white index knight index is black knight if it's black to move, and it just saves you repeating a lot of code. Yeah, so there's some error checking in this as well. And all I'm basically doing is just try. If it finds an error, then it will just return it down to the base function. So it'll just have like a try all the way down, like thousands of recursive functions. These are just basically, just for testing and then debugging. So if the starting square is out of bounds, then it's invalid. So if the target square is invalid, just basically test things. If the piece is invalid, I think this is, so if the piece is white and it's white to move, white not to move, then it's an error. It shouldn't be. It's wrong side piece. Same thing with black. If it's a black piece and it's white to move, it shouldn't happen. If the tag is out of bounds, it's invalid tag. If the target square and starting square should never be the same. Here I have promotion when not expected. So normally there shouldn't be a promotion in the starting position. I should remove this if I'm testing any other position that's not the starting position. But it's rare that I'd ever actually get a promotion from the starting position. Here I'm just saving the starting squares basically. I use ply to index it, and if ply goes, I basically have 10. So if it goes over 10, it'll give you an index out of range. So I shouldn't have that. Side before make move is for testing if you change the side, because I was an idiot before and didn't change the side, which basically I did this. And then, I forgot to put this here, because I was like, did I put it in the mace function? I just forgot to put it in, I think I forgot to put it in unmake move. So I basically test if I change the side for both. Obviously, it shouldn't happen. Here I test if black occupants are the same. So I get the white occupancies, get the black occupancies by ORing all the boards together, and then AND them together, be it just combine them. Or just see if there are any ones that are the same. Because they shouldn't possibly, the white pieces and the black pieces should never overlap on the same square. So they shouldn't be more than 0. So if it's not 0, there's an error and we haven't captured a piece correctly. Because the way bitboards work is they're individual. When you capture a piece, it doesn't actually remove, you gotta specifically remove the piece from the other bitboard. Otherwise it won't get removed. And that's just to check this. So the pieces are overlapping. Here, just, debugging for the last move. It's easier than finding the ply -1. It's kind of risky to do that. Again, we call this function again. We have the side before unmake and then check if it's that. Then we have all the copy bitboards. So we just check if they're the same or not. If they're not the same, I want to find as much information as possible. So what was the copy? What was the global bitboard? What's the capture index? Print all the bitboards and then print all data anyway. I just want as much information as possible. But I'll just show you this working, basically. Alright, so I run this. I think I'm just running the debug right now. So it's obviously going to be very slow, because I'm running in debug mode, and I'm debugging all of this. So of course this is going to be a lot slower than regular. But to show this works, I'm just going to introduce some errors and show you what I see when I debug this. Because I don't actually have any errors at the moment, because I found them all. And some of them are very stupid. Okay, so that's there, 20 seconds. Obviously, it took a long time. But let's introduce an error, shall we? Let's go to unmake move, and let's not change the side. And then see what happens. It says, error, side not changed back. So we find the error here. And we can also print the move as well. So say, for example, I got this error, right? Let's go... So try make move. Unfortunately, this will be here. So what I could do is I'm just going to print. I'll just copy this because I'm a lazy coder. Copy this and put it here, and then we can get more information. What was the move? What happened? So we want more information. So let's do that. So the position was. So the move was C7, C6. Sorry, C7, C6. This one. So C7 to C6. It tried making this move. And it realized the side wasn't changed. Obviously, that means the side wasn't changed, but you don't really need much data. You just think, oh wait, did I change the side? Or how did that happen? Sorry, I'm on print all debug. I went the wrong way. I went to here. It's like, wait, why? Ah, it's commented out. Okay, you find the bugs like this, or you can find other bugs. Maybe you could. So what I did before, like an idiot. So I was refactoring the make move. just to make it more function-based. So before I had loads of these, but here I just have move piece debug, and then if it's a capture, I simply just have a capture type as an enum, which is up here. None, capture against white, capture against black. And basically, if it's white to move, well, I've changed the side, so it must have been against, the capture was against white. So I set the capture here, if it's a capture. And I go all the way down here. I should refactor this, I haven't bothered to do it yet. I basically find the index. What I did before was I didn't remove the piece as well. You're supposed to find the index, then remove the piece. So if I remove this, then we'll get errors. So basically, you're just trying to find what's causing the problem. So what was the problem? What's the error? The error. Overlapping pieces, okay? So we have an overlapping piece. What's this? Let's look at the position. So the position was... Okay, I can't actually see the printing the boards. Maybe I should fix that. But anyway, if we can go through all the pieces, right? I think I just have... Yeah, overlapping pieces doesn't actually print the board. So we have the white pawns like this. Okay, it doesn't matter about that. I think it's the pawns. So here we have pawn. So this black pawn is set, and this white pawn is set in the same position. So it's obvious that we're not deleting the capture move when we make a capture move. I should also print the move. What I'll do actually is I'll put all the data in this, because I don't think I have all the data. Okay, now we're printing the board and we're printing everything. So the move was a b6 a5. So b6 to a5. So obviously this is a capture move. So we need to find, in a capture move, we didn't, overlapping pieces normally means there's a capture. There was a wrong capture, or a capture that isn't deleting the piece. So, it's a capture piece, and the pawn is the same here. So we found the error. Basically, we need to, we found the source of the error, and we go to make move, and then we look for the capture. Think, these are commented out. Okay, obviously I'm creating these myself. I had a very weird one. That I didn't really understand at all, that I couldn't actually find the source of. It took me a while to work it out, but basically that was the problem. So say for example if I remove this, let's remove this error. Alright, so go back to where I was before. So what I'm going to do exactly the same thing as I did before. I'm just going to remove this. And I'll show you the bugs I was getting before, which confused the hell out of me. But obviously there are just things that you don't think of. Right, okay, so what's the error here? Copy board's not the same. Okay, the copy board was not the same. What I did before was I didn't print all the bit boards. So in this position, the move was a6, b5, a6 to b5, and then it was taken back. So it was taken and then taken back. And it says here, copy board's not the same. So what was the copy board? Let's look at the copy board. So the copy board was this on 6, was not the same. Also, we have the move. I put the move order as well. So A2, A3, A7, A6, A3, A4, B7, B5, A4, B5. That was the move order. Just so I know the move orders. But it's basically, this is the global one. I should have a new line here, but anyway. This is the global one, 6. So the global one is this, whereas it should be this, because that was what it was before. Which tells me we didn't basically put the piece back, or there was some error there. But this doesn't really give me the entire picture. Was I removing the piece wrong? Basically, I didn't have this code. With this code, it becomes clear. So basically, yeah. So this is what I was doing. So also, I was extracting methods, and the problem is with this code is probably the most buggiest code I've ever tried to write. Because the amount of things you could forget, like you have the pins, you have check, do they work? Are you changing the side properly? Is en passant working? Is there an en passant check? Because check can go through en passant in some annoying situations in chess, which is just, like here I'll show you the en passant code. And basically, if the pawn's not on rank 5, it can't. If its EP is no square, then it can't. If the white pawn attacks, basically there's no pin or check, then if it's 0, it shouldn't be 0. With the EP square, then if there's not a king on the rank 5 bit board, basically there's a problem where you can actually remove the en passant pawn and it will actually put the king in check. So I have to check if there's a king on the rank 5 because it could be pinning the en passant pawn and the white pawn with a rook or a queen. So I need to check if there's a king there. If there's not a king on the rank 5, then we return true. It's the amount of like things that could go wrong with this program are ridiculous. Just with bitboards in general. Within arrays, they're a lot easier. And you could do a lot more lazy technique just because it's, performance. But there's so many bugs. Basically, what you want to do, if you have like a very, very complicated project that can have lots of bugs, you want to create something like this where you're testing literally every possibility to try and narrow down the bugs. Because what I was doing before with this to test it was actually just compare against Stockfish, which was tedious as hell. So I'd compare against Stockfish, okay, find the move, okay, well, first you got to know, is it a make a move error? Or is it actually a move generation error? Because when you make a move, it's when you change the board position or change it back. And when I was incrementally doing the occupancies as well. But basically, yeah, so you wanna try to implement this if you want to avoid bugs entirely. You want to just you can't avoid bugs, but you want to find them as quickly as possible. Just be as thorough as possible and just presume you're going to make an error. So this is my copy of the program in C#. I'll basically show you how I would implement this. So I have, I was testing out basically if functions are better, well, if there's a performance difference before I do stuff. The main reason I want console.readline is because I want it to load all the memory and then start. Okay, start. Okay, 788, start, 821. So that was with the functions was the second one. So it's slightly slow with functions. You test it other times, sometimes the other one's faster. It kind of depends on the situation. The functions are slightly slower when you separate things into functions, which is why I made everything in line. But anyway, so I was testing this to get it to work. I run perf debug. I'll show you how I did this. So first what I did was I created a struct called error_int. You could make this any value if you want. I decided to make it an int because that's all I need. You could make it, generic and just say error value and, make it generic if you want using like, this or, I don't know, something. Can't remember how you make generics in C#. I never bothered doing it half the time. Anyway, so public int get set. The reason I make it set is because we need to change the value. When we plus equals nodes, we need to plus the value. Normally you shouldn't make it set, but I need to in this situation. Then we have an error, which is an enum. And we have a load of errors. So all of these errors. Basically the same as in Zig, really. And then what we do, I'll show you back in, so run perft. So it returns an error int, right? And we have all these error checks, same as before. If the depth is less than 0, error int from error. We have this function from error, which basically just returns this as an error. And then error depth less than 0, right? And then we have this thing here behind all the error checking, which is ridiculous. So if nodes.add.error.hasValue, because this is an optional in C#, you have to say has value. So if the optional is not 0, so if you don't want to use an optional, what you can do is you can basically just make the error none. You could just have one here, none, like that. So you can say if the error not equals none, or something like this. But I use an optional because it's just, cleaner, more kind of idiomatic for the language. We use an optional. If it has a value, we return it. And I'll basically show you some errors, how this works in C#, turn it to debug mode. Let's just make some errors, shall we? Let's not change the side, for example. I'm going to show you what happens. Okay, so here, yeah, so it doesn't actually print the board in this situation. So it's a side not changed back. Okay, the side error, okay. We can just go to here, unmake move. Unmake move. Okay, that's commented out. Okay. Or we can maybe, let's break a capture, for example. I haven't actually done the capturing, I think. In the black capture index, I think we actually delete it. Yeah, we delete it. What I'm going to do, I'm just going to delete this. And we're going to test and see if it detects it. Apparently it did. So with the depth 3, it didn't find an error. Mostly because depth 3 doesn't get to a capture. 1, 2, 3 doesn't capture anything. You can't really capture. In theory, you could. There is a capture of the... Anyway, doesn't matter. We'll go to depth 5 and we'll get some errors. So copyboard's not the same. Okay, what happened? We know what happened. We create the error, but... it doesn't give us much data here, so I need some more information. So copyboard's not the same. And then we print that. Right, so now we're printing all the boards, and we're also printing the copy and what's wrong. So there was a pawn here now, so there should be a pawn here, but there isn't a pawn here. So that tells us basically that we are Alright, so basically, I guess the bishop captured this pawn, and we needed to put the pawn back, but we didn't put the pawn back. So this tells us that we are not putting the pawn back when it's a capture, so we should look into the capture moves. Obviously, we'll find that we make the move, we look for this, find white capture, and we this is commented out. Obviously, we're making the bug ourselves, but basically this shows that you can in theory do this in any language. I mean, people have done this before using like enums for error checking, but probably not as thorough as this. And that's basically what I think Zig kind of promotes a lot of the time, is basically testing things and finding the errors and making sure you can find it by making error checking quite simple and kind of inbuilt in the language. Because in C# you kind of need to, go out of your way to make this. You got to kind of make an error int. In theory, what you could do is you could just pass by reference everything and then just return the result if it's an error or not. So this is basically just how you can use Zig to find errors, how you can use the error system to find errors and debug things that are pretty complicated to find, and just presume that you make mistakes, because we do. We all make mistakes, and your code almost always has some bugs somewhere that you didn't think of, depending on how complicated the program is, and you always want to test edge cases. But thanks for watching.